Good morning, good afternoon, or good evening from where you're joining us. Welcome to ABB Process Industries webinar series on sustainability. This is the first out of the 3 sessions on how digital champions manage energy. Whether you're joining us live or listening to a recorded session, we are delighted to have you with us. I would like to introduce our digital expert on sustainability. We have Anis Korchi, a digital portfolio leader for sustainability, Nazneen Asari, who's a solution consultant for sustainability, and Irina Deschamps, who's a product marketing manager for sustainability. For about 30 minutes, Nazneen and Anis will take you through real-life examples of energy management across industries, and we will also outline the key elements of a successful energy management strategy. Please note that we also have polls configured on Slido, and we request you to please participate in these polls. You could scan the QR code when the slides appear, or you could just go to slido.com and type in this code that I'm now pasting in the chat window. Ken, thank you very much for joining us, and I hope you find the session valuable. Over to you, Anis.
Thank you, Archie. Thanks, Archie. So I think everybody here today would agree with me that sustainability is making the headlines and everywhere. A recent report from the International Carbon Disclosure Project, the CDP, found that 80 to 100 companies out of the 4,000 that were interviewed about their net zero commitments had a credible plan. And this shows us that the sustainability puzzle today still remains unsolved widely. And one of the reasons is that the technologies beyond digital are not always and completely developed or adopted to support that effort. But it doesn't mean you need to wait for all the pieces to be there. The most advanced manufacturers were very early to realize that managing energy has become a key competitive advantage. Indeed, digitalized energy management is one of the key elements of any sustainability strategy. Everybody's agenda is now influenced by energy price variations, social reputation concerns, capital market expectations, and regulatory issues. But some companies have made more progress than others, and we call them the digital champions. This is because they use a more automated, data-driven approach to sustainability. This opens them the door for higher productivity, carbon footprint traceability, new business models, and access to capital. This way, they can offer greener and low-carbon products. So as we saw on the previous slide, there are very strong action imperatives, but it is surprising that many opportunities remain untapped. Our goal today is to look specifically at energy and digitalization, show what is possible based on real-life examples of companies, how they integrate sustainability into their daily operations, and also help you promote improvement opportunities and bring new ideas within your teams. On this, I will now hand it over to Nazanin, our sustainability consultant, and she will take us through some real-life examples of what we call digital champions. Thank you all.
Thank you, Anis. So our first example is from a paper mill. It was suffering from downtime caused by power consumption limits. After performing a detailed assessment, a list of improvement opportunities was identified. In this case, it was necessary to upgrade faulty maximeters devices, which used to block power consumption when it reaches predetermined limits. And in addition, a new energy monitoring and reporting system was also implemented, covering electricity, natural gas, and other areas. The company not only solved the problem of the downtime and avoided penalties, the resulting energy saving reached more than 9%. CO2 was reduced by about 1.5 thousand tons per year. Of course, it was a combination of measures, energy-saving hardware improvement, and less capital-intensive software-driven improvements focusing on operations. Generally, the trend we see is that sustainability managers often use our software to evaluate investment options. It helps them demonstrate to the management what impact can be achieved by replacing some of the equipment. EMS also helps the regular in-house assessments. When the employees consider energy as a manageable expense, they can analyze it more critically and become more aware of how they do day-to-day actions and affect the consumptions and emissions. If you want to know more about this case, you can just click on the article that will be shared with you later in this PowerPoint. Moving on, measuring energy consumption of equipment is the basis for the calculating energy efficiency and carbon emission. And even if monitoring and reporting is far from new in the industry, the objectives are changing fast. There are no two plants use energy the same way. More and more data sources needed to be need to be integrated. Let me give you a few examples. A large cement producer monitors cement operations, a captive power plant, different fuels, and the calorific energy. They also focus on power quality, track losses on the distribution and transformer side. Another company, for example, mining, is using our software to centralize monitoring and reporting across several mines and harbors. It drives their continuous effort of reducing carbon dioxide and sulfur dioxide. For enterprise customer, the efficiency, ESG compliance, and productivity gains coming from the automated reporting are considerable. Another interesting example is from metals. Their energy networks are very complex. It includes gases, process steam, compressed air, LNG, and more. The system establishes a transparent energy consumption and cost structure by department, production line, equipment, then to end product unit. Using ABB Energy Management System also helps our customers obtain and maintain ISO 50001 certification. In this regard, I would like you to take part into our next poll. I would like you to share with us, is your site certified according to ISO 50001 Energy Management Standard? And what I would like to share with you is that it's a good way for you if you use digital energy management to obtain and maintain ISO 50001 certification. So if you don't have any certification, we can also share you more information about the benefits. Even if the countries with uncontrolled consumption of cheap, heavily subsidized energy are present, they are still increasingly adopting to this standard. And ABB is a pioneer in this regard. And as we stated, and we started this also in our factories. So as I see, many would actually want to get certified in the coming year. So maybe the next story would be interesting for you. Thank you. So as I mentioned, we are also a pioneer in this because ABB is a technology and software company, and it's important also to lead by example. We currently identify areas that we can reduce our CO2 emissions at least by 80%. As the technology evolves, we always seek opportunities to do more, to make more sustainable targets, ambitions, realistic and measurable. And this requires a good data and analytics and continuous tracking. That's where our EMS software helps our own factories. In this case study, I would like to show you how it is used in our 14 business units across ABB Finland. First of all, it brings transparency and clear goals for different energy types. If it's electricity, heating, water, then there is automatic notification which alerts users about deviations and abnormal behaviors within the site. Anything related to consumption, emission, energy prices, water leaks. In addition to that, we go beyond energy monitoring and reporting. The EMS also receives production plans from the planning systems. They are used to calculate corresponding energy consumption schedules, and once you get reliable consumption forecasts, electricity costs could be reduced substantially. Now that production departments are very motivated to improve operation planning, they can monitor actual consumption in real time and even plan better next time. Beside ABB factories, similar digital projects for energy forecasting and planning have been implemented in the pulp and paper and metal industries. Again, each company has different processes, local energy market rules, and supplier contracts, but overall reduction of 2 to 5% of company total energy costs can be achieved thanks to more accurate energy forecasts. For example, in a steel plant using an electric arc furnace, load changes sharply between 0 to maximum power during a melt cycle, which is about 50 minutes. If the consumption schedule is not correctly predicted, the electricity supplier incurs additional cost. These costs are transferred to the user in the form of penalty charges. The steelmaker also has a rolling mill with its own consumption profile. Our software enables centralized power procurement. In this case, it's in a 30 minutes with its own consumption profile and do the 30 minutes forecast. But we can apply different time steps starting from like 15 minutes. A pulp and paper mill, with a mechanical pulp line, pulp machines, internal steam, and power production, requires a different forecasting method. It depends on the paper grade, production speed, and plans. And in all cases, operators monitor electricity demand by contract. The system activates an alarm if there is an unexpected deviation leading to a penalty. With our next poll question, it would be great to see how relevant this kind of use cases would be for you. So I would like to know how you are forecasting your energy consumption toward the vendors. Do you use average, your actual product plan, or you just don't forecast at the moment? So to give you this information for your forecast, if it's based on the average, there is certainly a cost saving potential on your side. And the return of investment is usually, it's just within the months if you're doing that. And to also note, the more dynamic your energy procurement, the more optimization opportunities you can find. And to be able to digitally orchestrate demand and supply, I would like to invite you to see also our next case study. Okay, thank you. So here I would like to show you some of our customers who are participating in the electricity market with highly volatile spot prices. Here in Austria, we analyze their production processes. Are there any energy intensive steps that they may, and if there are some flexibilities there. And our EMS can then shift these steps to times when the electricity is cheaper. In this example, there is a mechanical pulp mill in Austria. After implementing our software, they have reported almost 15% total savings. There are saving examples over 2 sample periods when the optimization was possible, and the results were utilized by operators. Our software automatically recalculates the load schedule based on the real-time energy prices and production targets. That's why it's so valued by the customers, as you see in the code. If you want to know more about this case study, please use the material is shared to you and the online article to know more about it. Moving to the next case study. This one is in the cement industry. The objectives and operational constraints vary a lot here. They depend on restrictions in material transport and storage, planned and unexpected maintenance, complex energy tariff schemes, equipment power startup curves, and other things. One day optimizing the energy tariffs may be the main goal, and the next day reduction of carbon emission is the goal. We make all this information available in the same system. Energy tariffs, equipment availability, product demand, silo inventory, and more. Operator can choose his own objectives before publishing a production schedule. When the goals are changing, he can verify consequences by evaluating the several what-if scenarios. This is particularly relevant for cement plants. They are constantly looking for ways to minimize deviations from emission limits and achieve higher profitability. By coming to this, I would like to tell you that we have developed many other digital models for holistic optimization and demand of supply across many industries. I'd like to invite you to join our second and third part of the webinar series. We share more advanced optimization case studies, and please keep your questions coming. And we have also one more poll question for you. So here we would like to know if you already have flexibilities in your processors or energy mixes. So can you reschedule your production without interrupting the rest of the processes? Can you switch between several energy resources when the other one is cheaper than the other? And you don't know about the flexibility on your site. Unlocking flexibility is a fascinating area. It holds highest optimization potential, which is only possible with the digital tools. As I mentioned, it's a complex place. That's why I hope you join our next sessions in the next 2 and 4 weeks, and we can discuss it more detail. And for sure, we can help you to identify those flexibilities in your operation and also have a more digital way of interacting with those complexities. For today, before we move to the Q&A, I would like to have a summary of what we discussed today. And for that, I ask my colleague Anis to take over. Thank you.
Thank you, Nazanin. So, as a summary, I would like to say that my key takeaway here is that an energy management system is key to introduce in your industrial processes. It helps you go through a beneficial cycle of energy monitoring, then you do the forecasting, and later on the optimization. And going through this cycle, it will enable you to get towards your sustainability goals. Concretely here, we will enable your sites to get the ISO 50001 certification. We will also enable your sites to provide a central system for all data related to regulatory compliance and set the road for carbon neutrality. In addition, this cycle will also help you reach some energy cost reductions. Typically, we would expect 5 to 15% cost savings that would materialize with energy efficiency projects or programs. Those ones would require some capex investments on your site in addition. For example, you would change a motor, adding a drive system, changing the process by itself. But also, it can also be materialized with real-time optimization that I will describe in the coming slides. We have thus developed a comprehensive energy management solution that takes you through this cycle. And the solution is packaged into 3 different modules that you can subscribe to them independently. Starting from the module number 1 that we call monitoring and reporting. This module will replace your multiple Excel files and fragmented systems into a single and modern real-time solution that would enable, in general, 3 use cases. The first one, it brings cost structure transparency of your energy consumption also. It can be very granular at the equipment level, but also higher level at the process, plant, or at the enterprise across the plants. It will also give you a good visibility on all the energy metrics you have in your site, be it the water you use, compressed air, gases, electricity, steam. Those are the so-called wages. Greenhouse gases are also tracked via the concept of emission factors, and we can also go one step further with a more precise estimation thanks to our software called PEMS, and it stands for Predictive Emission Monitoring System. This is a machine learning type of tool. We will not feature it today in this webinar, but we will have some discussion points about it in the coming 2 webinars in the next 2 to 4 weeks. Another interesting use case that we associate to this module is the anomaly detection and the alarm management. This will help you be reactive and quickly act on the field in case of any energy inefficiency. An equipment is breaking down, a motor is getting old, you would identify that earlier instead of waiting for the next maintenance shift in a few weeks' time. Finally, I see this module as a decision support for your energy efficiency programs. You will be able to look at historical energy data, look at the correlations between the different parameters, and identify opportunities to improve. You can go one step further and allocate an action owner, track the execution and the benefits. So typically, this module is used by the operation managers, the sustainability and energy efficiency experts, and also the operators who are driving continuously the energy efficiency and ESG compliance. Moving through the cycle, we have now the second module, and this is what we call forecasting and planning. The core strength of this module is the ability to do energy demand forecast based on production plans. The main use case we see is that it helps you plan for the right level of power purchase, especially in the liberalized power markets. This solution will enable day and week ahead power procurement planning, but also intraday power purchase with 15 minutes, 30 minutes, and also 60 minutes time intervals. The use case of power purchase is quite relevant nowadays because we see several industrial plants shifting to the 15-minute imbalance settlement period, the ISP, for their power purchase. And this shift will require a lot of data manipulation, and it will not be possible to keep doing that with simple Excel type of tools and also some homegrown dashboards that you may have in your sites. Another typical use case we have with this forecasting module is to predict unexpected temporary power peaks that generally comes with a penalty cost from the grid operator. And finally, we would help you design the best production plan given your power and energy constraints. In here, you can create different scenarios and see the corresponding power and energy needs. The typical users are the ones I have referred to just now. So we think about the energy procurement manager, but also the production planners. Finally, we move to the optimization case with our module. Here we will provide 2 types of optimization in general. The first one is about energy demand scheduling. The idea is to schedule automatically operations at times of lower energy prices. This would be possible for processes that have the flexibility to switch on and off or generate some delays. We would think about, in the pulp and paper industry, of the thermomechanical process. We can also think of the electric arc furnace in the metal industry, in the steel melt shop. Another optimization lever we have is a better energy supply allocation. This is quite relevant for sites that have access to various sources, be it a grid access. You may also have your own powerhouse. In addition, you can also have some renewable energy sources on site and maybe some energy storage. So how do you balance all of that in a dynamic way, taking into account external parameters like the weather data and also the electricity price in real time to meet your loads at a minimal total cost? So those are the 3 modules that we have in our software. Module 1 and 2 are quite productized. They can be installed relatively easily in your sites. The module tree of optimization would require a bit more assessment to understand those flexibilities you have in your operations and how we can leverage them. So before we end this webinar, we would like to do a quick summary of what we have seen. And we would reflect back on the title of this webinar, which is How Do Digital Champions Use Energy? And here you have some elements of answers. And the first key one is that those champions, they have established targets with deadlines. Targets can be highly granular at an equipment level per ton of production. It can also be at a site or a process area. In addition, they have set up notifications, alarms, and reports to track their energy use against those targets. And then they have associated that with internal workflows so that the right people are looking into that and acting on the deviations. The next step would be about the forecasting to improve the energy procurement process. And after that, we have the optimization so that you can optimally balance on one side your energy sources and on the other side your energy loads. So thanks again to listening to us today. Just before the Q&A session, I would like to invite you to our next webinar. It's in 2 weeks' time on the 4th of May. We will go through some real cases of what we call digital champions. Those are some of our customers. And in addition to that, we will have a live demo of our software, the energy management system for industries. I will now hand it over to Arti for the rest of this presentation. Thank you.
Thank you, Anis. Thank you, Nazneen. Would like ABB to contact you for industrial energy management and performance and improvement potential. Please type yes in the chat now. You can also use the contact us form. There's the QR code on the screen. Please feel free to scan that. And we look forward to having you for the next sessions as well. Let us kickstart the Q&A session now. Nazneen, I think this first question is for you. Does the system also spot the symptoms of power quality issues?
Thank you, Fran. Yes, we do support power quality issues. Normally, you need the specific meters that measures this kind of quality issues, and we are capable of reading those data out of the meters, so we can then handle the voltage imbalances, harmonics, power factors and frequencies, power losses, and then we have also an interactive single line diagrams, which you can then basically provide the information from.
Thank you. Anis, this question is for you. Do you also forecast renewables?
Thanks, Arti. So I think to answer this question, I will start from maybe the use case where we need to do that. As we are getting towards a world with higher electrification, we see the need of more and more renewable energy integration, right? Especially in remote areas. And in that case, yes, we have to forecast the energy we would get from solar panels that we may have on the site. We will do that by using the weather data. But this is not the only thing we take into account into the story of renewable energy integration. We will also take into account electricity prices on one side and also the entire energy source we have on the site. We will then modelize the flow of those energies all together and then run our optimization algorithm, which is kind of dynamic and real time to balance I would say, the entire orchestra or the entire ecosystem on the plant.
Thank you, Anis. Moving on to the next question. Nazneen, are there any connectivity limitations to legacy systems? How open is it?
We are open regarding to the connectivity, so we communicate with the OPC and Modbus TCP, which are the basically standard protocols in the automation area. We are also open to provide information via OPC and RESTful API to a third-party system. Nevertheless, we are capable also to do specific integrations if there's something coming during a project. So um, in general, we are vendor agnostic, so we can communicate with the other vendors if necessary.
What is the implementation process or approximate timing to implement an EMS solution? Nazneen,
This
Anis?
one, I can go for this one. So I would say so we have the process. So we have a product, yes, but we will still do some time to specify the needs of the client. Then we will typically go into the project execution with various steps, including either interfacing with the customer sites, getting the data, generating specific calculations for them, and then we have the commissioning and the testing phase. All of that would typically take at minimum 3 months for the most simplistic case of a simple monitoring installation with a few energy metrics to look at. However, that can go much beyond depending on the scope of work. So scope means here, do we do only monitoring or forecasting or optimization? It also depends on the size, as I said. So is it only few energy metrics with few data points, a few variables, or is it much beyond that? And finally, it also depends on the customer maturity. Is there a digital infrastructure in place? Do they have the meters also in the site to be able to pull all of that information? So to keep a number in mind, minimum 3 months, but then it can go beyond that.
Does ABB perform energy audits and energy efficiency project implementation?
Yes, I can answer that. We do perform these kind of services. We can help you to identify the inefficiencies on the site by doing the audits. If we don't limit ourselves to just a software solution, so ABB has also a wide portfolio to offer also the hardware needed to be replaced. And we have also other parts of our digital portfolio. We can help you if we see that their optimization can be done on the process level or on the asset level. So all of those can be provided by basically doing the audit and identify the inefficiencies on the site, prioritizing them, and also knowing what is roughly the return of investment for you and where you can actually have the low-hanging fruits and quick wins.
Thank you, Nazneen. We have one last question on the chat window. Anis, this one is for you. What is the difference between power management and energy management systems?
Sure. So the power management systems that we typically call PMS here would sit closer to the control system, the DCS, for the electrical process. The main user would be the control room operators, for example. The time frames would be very quick to the second level. And EMS on our side, what we presented in the previous slides, would be something like an enterprise software for electricity, energy sources, but also water, air, diesel. So it has a larger scope. The solution we have here sits at a higher level than the PMS. Of course, it can communicate with the below level of level 2 and provide guidance. Main users here will be the engineers and environmental specialists. It can also be the executive team of a company who wants to have a big view of their energy footprint and also carbon footprint. And also in the time frames, we are not as fast as the PMS, closest to the control system, but we will be around the minutes, 15-minute steps, hours, week, months. That's how I would reply to this question.
Yeah. Anish, there's one more question that has popped up. What is the advantage of monitoring software compared to a Power BI?
That's a good question. Thanks. So Power BI specifically, I would more speak about general dashboardings. Yes, with a dashboard, you can pull your own data and then display it in your own way. However, you will not be able to go beyond that of doing the whole forecasting use cases and the optimization use cases. So that's one element of answer to keep in mind. But even if we look now on the monitoring aspect by itself, starting with the dashboard, it means you start from scratch. You will not know what to show, what to analyze, and, and 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 by having an EMS product that relies on, I would say, 10 to 15 years experience in that market, you will benefit directly from the best practices that we have embedded into that. Um, but also don't take it as an EMS is something which is fixed as a product. We will still allow ourselves some flexibilities to adjust to your constraints. So we will have a product 80% productized, and we will also allow some customization to your constraints, like a dashboard will do. Another element that you may not got with a dashboard functionality that you develop in your own organization. It's the whole life cycle of maintenance of the product, the service support. With that dashboard, you will have to do it on your site. Here, you will have a full team behind supporting you. So that's my view here, Artie.
Yeah. I think, yeah, the questions are done. So we thank you for joining the session, and we look forward for you to joining our next sessions. It's on May 4th and May 18th. And please don't forget to type yes in the chat window if you would like us to contact you. Thank you very much. The recording and presentation deck would be available to all who have registered to the webinar. Thank you.
Thank you very much.
Thank you.